Hello everyone, this is SerpApi podcast. Today we are going to discuss how to continuously test and maintain a web data scraping API. We will share our approach that we use on SerpApi. So we support tens of different target websites on that on multiple devices, on multiple locations. I mean, multiple localizations, multiple form factors, also previous and current versions, A/B tests, and stuff like that. So we have several thousands of parsers code that is written in Ruby, and we use our spec for our tests. And yes, and we with Emirhan will share our approach. And Emirhan, do you want something to say?
Oh, yes. So I think we need to start. It's better if we start from scratch. Like, what is unit testing, and what purpose should it achieve? I think that's a great way to build up upon the conversation.
Cool,
So
great.
for us, I think the if you were to categorize different kinds of tests, the simplest one should prove that the parser is working, and the customer will get what he or she desires. Oh, it's just you. Okay, I'm sorry. I was just looking at the chat.
No worries.
So perhaps I don't think of anything that is lesser than that, although it is essential to prove that a parser is working. This kind of approach is not continuous, because like if you say there is this element which we scrape this key from this part of the HTML body or whatever form that we scrape, then it is going to prove that it is working. But in dynamic structures, like for example, we use different proxies, different user agents, so the input that we get to scrape that data might be different. So a unit test should hold for different cases and also throughout different times, so that we have a better understanding of what is going on. What is it good for, apart from proving that the parser is working? It would also help in the future to see for if another engineer works on it, or if you work on it and if you forget about it, it would help you understand how what to expect from a parser, like what should its purpose be, so that you can get back into the unit test and then understand the possible outputs, and then what is missing, what is not missing. You may be able to see them. So what is the risk with this kind of testing? I would say the first of all, false positives, like the trouble of the century. False positives is a big thing, because it's you think the test is passing, but it's not. So that's something subtle. That's something that will give the customer a headache, and then he will complain, and then we will fix it. So it's not good. Another thing that it achieves, another problem that might arise, is that the structure might have changed completely, so that you are passing another part of the body as somebody. So you're actually mixing things, but because you check for its presence and its type, it's creating this weird problem where the test is passing, but you're actually serving a different kind of data. Do you have anything to add to that? Like, this seems like the simplest way that we can take an approach, which is also now public unit tests.
Can you rephrase your question?
I said, do you have anything to add? Like, do you have anything in mind that I missed?
Yes, like you talked about unit tests and like I'll probably share like what kinds of tests, what kinds of actual unit tests we have. So we have unit tests for our like parsers code, and we have integration tests for like kind of integration tests for our like also parsers and also like overall like entire application. And for like regarding unit tests, in order to speed up our tests, we store HTML files of different HTML responses. And sorry, am I repeating what you said, or
No.
did you have?
I
Yeah.
was just asking that, like,
Mhm.
for you to expand the topic.
Yeah, sure. So we store HTML for different layouts, different language localizations, different form factors, and different versions of each target website and of each widget that we support to be extracted. And we do it to speed up our test suite, because before we did that, and also we do it to make our tests more reliable, because before we switch it to HTML, basically before we switch it to HTML fixtures, we were doing real requests to like they were like end-to-end tests. So we made a request, we parsed the data, and we checked the response schema. So either test is failing, and tests were flaky because sometimes data, because HTML is different when we like fetch it from the real like target website. And then we switch it to HTML fixtures, and our parsers became faster and more our tests became faster, also more reliable. But that introduced another problem, that's about outdated fixtures. And right now we are manually updating our HTML fixtures, so we're adding new files. So we created a rake task. Rake task is like in Ruby, there is a task runner that's named rake, and we added a rake task that gets all of the that iterates over all of our integration tests that uses HTML fixtures, and making another request using the same parameters to the real website, and saves HTML and updates our spec file. So we have a kind of automation to update our fixtures, but in in production code, we don't monitor changes on target websites. We have error monitoring, and besides error monitoring, whenever target websites updating their layout or adding something new, or anything else that makes our parser not being able to extract the data, we have to manually check that something is not parsed. Either our customers telling us that there is some bug, or we find that bug by ourselves. Because most of the times when parser is not working, it's not resulting into an error. It's resulting only in like some missing data.
Yeah, that's actually an important detail, like because the customer might not be looking for that part of the body that is broken, but somewhere else. So it's good to safeguard the code into not failing, not giving any 500 errors.
Yes, and What do you think? Like, what? Like yesterday or the day before yesterday, we discussed some part of your work where you told how we could improve our tests or something like that.
Yes,
But
yes, I can build into that. Yeah.
Mhm.
So here is the thing: to take the subject into categories, make the subject into categories, so we can prove that a parser is working, and we can automatically add HTMLs and update unit tests, which is a good thing to maintain, which is a really good thing to maintain because it isn't actually intuitional for an outsider, but it's actually a really good method to with one terminal command you can update all the tests. That's actually a great way to maintain an API. But the object of the test should be to give less complaining to the customer, less time spent on finding issues, and then the test should be able to find the issue by itself, so that you don't have to worry about anything else.
Mhm.
So, but for that, I think there is actually one more step to it. But for a unit test or any kind of test to find its own issues,
Mhm.
you need a static fixture from not fixture but static layout from the HTML. So there is a good chance that you may be using something too specific when you target an element, and that is actually a problem because so it's not actually about unit testing, but that
Yeah.
is actually a problem because this means that you may be taking something else into the unit testing. So however much you have a good unit test, you may still fail. Like you may create the most beautiful unit test out there, but because the CSS targets or the expat targets are too general, for example, it might work for that case specifically, but not might create a good solution in the long run. Then
Mhm.
that unit test should tell you something, but it's almost impossible to make it without that duo. Like the maintainer of the parser and the creator of the unit test should be the same person, which, by the way, surprisingly is not in many companies. Like unit test is a different thing, and then
Mhm.
maintainers are a different thing. Like it's mind-boggling to me that why
Mhm.
wouldn't someone write their unit tests, So the objective of the unit test should take much responsibility from the customer and add it to us.
Mhm.
That's what I look at the unit test as. Customer shouldn't give us too many details. If something breaks, customer shouldn't give us anything.
Mhm.
To be exact, like the ideal goal would be that they wouldn't face any problem, and then we would find it automatically by ourselves.
Mhm.
But that's not the real world scenario here. So if they find some error, like there is something missing in this JSON output that you have given us, and then we should be able to catch it without any doubts. Like, oh, okay, this part is wrong because the unit test is showing this part to be the wrongful part, and this is a good way to handle a problem. And then here is the thing there, like unit test shouldn't satisfy your superior. It should satisfy the customer. And the previous type of unit test that I've talked about, the one that proves that a parser is working,
Mhm.
is only satisfying the superior. It's not actually adding up any value that is like, it is adding a value, but continuously thinking it's not actually adding so much value into into what we can alleviate from the customer, because we don't know for sure if it's going to break. Like, you can check it out, but it's not for sure, because the structure that we are passing is too dynamic, and we already have like too many engines, so it's almost impossible to find a common way to handle them. So the way I would say that a better unit testing with continuously, like better unit testing with continuous approach would be to use machine learning. Yes, that's what I suggest. Because here is the thing though, like if you have something that is costly and slow, but gives a more precise output, you can use that thing to test less pricey and more faster approach. Like, you can check the outputs of that clunky system, but it is more precise, and then put it into your the system that you use to serve the customer, and then create unit tests with continuous iteration, so that you have, like, for example, we have something of a sort, for example, that we search for the real search pad and then take the first organic result, for example, and then check if an organic result is missing something. But that is a flaky approach, because that's also causing, like, sometimes Google or some other search engine might not serve that one key, and it would create an error. It's good for us to look into it, but most of the times it's like disregarded in all cases, like not just SerpApi, because if you have a test that is flaky, you tend not to get serious when it breaks, like, because it might be a false positive, false negative, which is also another problem, false negatives. So in order to save that, I would suggest that machine learning is a good solution. But how do you test machine learning? That's also another problem. Because from what I see, from what I get it from people around me, is that there is a threshold that accuracy must pass within machine learning integrations, and that level of accuracy is actually randomly decided most of the times. Like, there is no, how do I say, if it's not overkilling something, then you already have a flaky system, which is what I did with local pack parser. Yes, local pack parser. So I was like aiming at different English language Google web pages, and then getting a 70%. And that's actually a number that I came up with within the test. So it actually doesn't have much value than proving that it is working. And it's actually not communicating with the next engineer if someone is going to work on it. It's now actually communicating with the next engineer, because it's giving a more precise result when it comes to US, but less precise result when it comes to Australia. And it's like the average between them that gives the 70%. So it's not actually, not the average, or minimum that it gives is the 70%. So if it's giving 70% on Australia and 90% on US, it's actually something that is good, because if your customers are mostly on US like us, but it's also still flaky, and it's also still hard to explain the logic to. Whereas if you have something that is more traditional, more static approach, if it's taking this key or not, then you have something that is more usable, because you don't have any confusions about what you do. So I would say a mixture between traditional unit testing and the testing using machine learning would be a good duo to continuously maintain parsers in general, web scrapers. What do you think?
And I have questions. Can you explain more, like how exactly how exactly machine learning can be used for tests, like to generate data or to validate variance of inputs or what?
Validate variance of inputs.
Uh-huh.
Generating data is another thing,
Mhm.
which you can use to. So generally speaking, generating data in machine learning is. I don't know how we came to machine learning again, but
Because it's
generating
interesting to you.
generating data in machine learning is mostly for machine learning. So you create a data from a better how do you say, better model to train a lesser model into being better. So you train you take this smart kit, make it train the dumb kit, and then use the dumb kit for a lesser fee.
Mhm.
So I dumb kits, by the way. There's nothing to do with that. So it's like generally speaking, creating data is for that. But I would suggest, for example, you just changed ML with Emirhan. Interesting. So I would say that checking inputs is more important, and that is for now. Like in the future, I don't see anyone doing what we do, and I don't know how many years, but nobody is going to look into elements and then their structures, and then if we should find some structure target that needs to be holding itself to throughout the time. These things take too much intuition, and it's like almost impossible for generations to hold this information. Like we will have a solution in the future where we automate these intuitions.
Uh, I want to comment the part about validating the parser output, variance
Mhm.
of it. But we can, like, anyway, our responses are not really like they are dynamic, but they are not random. So we still know about like entire variance, and basically what like our tests right now are testing response schema, like mostly, and we can store multiple response schemas. Like we know, like we send responses to customers, and we have an access to like everything that we send to like every JSON, and we can use that to save like somewhere, and like we actually store it for 30 days like cached, but we can get all of the different variants of responses and combine them into a single response schema. Maybe like I'm not telling about
That's
JSON
actually a
schema,
really good idea.
because if
I
if
get what you mean.
because if you will use JSON schema, it will be like a million lines of code. I mean, not code, but million lines of JSON. But
Not really. I mean, if
if
you have like unexpected fields, and then if you have a
Mhm.
smart enough system to differentiate between them,
Yeah,
so
maybe,
you wouldn't
yeah,
have a
and
problem. But what you said is a really good idea for the future. Like it's really good. Like I had two requests from the customers that a JSON schema of some sort for like whatever is present in, what was it called? the documentation of
Yes, yes, I
open
remember.
API documentation, if I'm not mistaken. Like they wanted a JSON schema to see what to expect from the fields. And that is actually a hard problem for us because that is changing, and we are trying to give that information in coherence rather than giving outputs most of the time, because it's a really hard thing to do, to give outputs, the expected outputs. Like sometimes we have nesting structures, and like by keeping the key name of the keys convenient for user to understand, we can bypass that problem completely. But what you just said is a good idea for creating a response schema and then maybe using it for unit testing.
Yeah, like I've initially came with that idea when I joined SerpApi 3 years ago, and like it's
Still
my
in development.
yeah, like it follows me like every day, that idea. Like I see
I'm glad
JSON
to help you
scheme.
with one.
I see JSON schema in every like issue and pull request that's related to documentation or test because it's like that's how I generalize this problem.
Yeah, that's actually like there are many things that I cannot think of now that you can do with a response schema. You're right, especially in like. So we're not going to have some key that shouldn't be appearing there. That's another thing because we didn't set to do that, or our parsers are not creative parsers, which is something else. Yes, I was going to mention this. So let me say one thing that might be useful with combining it with machine learning, which is just an abstract idea, not something that is a reality now. But we can use that response schema to name the new fields so that whenever there is a new field, think about a system where you are warned by, think about a smart system where it can differentiate between an old part that you are passing and then new addition within that field. And it could give you, oh, look at this. This is a new field that you must scrape and give to the customer. What if we had something that would also name it? Like, for example, if there is, for example, movie information within that new field, maybe you should call it movie hash and then name or title, number of views, something. Would take the reference as the JSON schema, which is an abstract idea, like a man can dream, but it would be excellent for us and it would save a lot of time from us and from the customers.
How to implement it? Do you mean match response fields or like how?
No, creating new response schemas out of old response schemas.
Do you mean to have a naming convention?
Yes, naming convention that is based on the previous one. And also generative naming. Like we don't choose the name, but it is actually chosen for us.
And then we would need to not only debug and maintain parsers, but also debug and maintain generators of response
Not
fields.
really. I mean, here's the thing. There is a split in the internet right now where there are so many fields that don't actually, how can I say? Like, for example, local parser, right? So it is classifying using tokenization. Not right now, it's not integrated, but the PRS. So if you do it once, you don't actually need to update it 1 year later because it's not going to, like, the language is not going to change that much. So you won't actually need to change anything into anything because it's not how do you say? Maybe not, that example is not good because it's also using the regex to support itself, but you won't actually need to update it if you use something that is dependent on the language and not on the structure in majority of the cases. So to test that is, like I said before, like finding that 70%, that is minimum. And that's just to say that it's passing, you know? So I wouldn't say no. I mean, I would say it might not be necessary to continuously test and debug that structure. Like semantic models are, maybe I'm missing something, but it seems to me that semantic models don't need much testing.
Interesting. Like we have several interesting ideas to try out.
Yeah, it's just, it has somehow become a brainstorming session.
That's good.
It's good though.
Yes. And so we have covered a bit tests, and let's also talk about maintaining parsers in Web Data Scraping API. Do you want me to ask questions for you, or we can do that?
Whatever you would like to do.
Then, I know how to start. What's your experience of maintaining SerpApi parsers? Like, how do you feel about
Really
it?
good question. So, my experience in maintaining SerpApi parsers is that in terms of tests, I think they're not enough, but I think from where we are, it is astonishingly easy to maintain something in terms of testing and structures and parsers, because you don't really have to worry about if the test is written good, like if it's in review, if there was somebody who took his time and looked at the test and then see that there is no problem with it, then in the future you have a good way to handle that problem. And that's the case with us. Like, for example, if there is some mistake on some part, it could be resolved within hours. So that's actually a really good superpower to have. My personal experience is that I find RSpec to be a bit problematic because it's most powerful part, which is the structuring, that is intuitional, is also limiting because we have scenarios where we have to do various things. Okay, RSpec is a bit problematic. I love RSpec, don't get me wrong, but here is the thing. Like, for example, the one example that I would give is that when I was working on Apple App Store API, where I was testing different sorting mechanisms and seeing if the body is different on each sorting parameter. And I actually worked on that test with you. And the solution I came up with doesn't look beautiful because it's using a commented example. And it takes, the comment is there to automatically add the second page of the results, for example. Oh, I think it was pagination, not sorting. Sorry.
Yeah, pagina, yeah.
Yeah. So that doesn't look good, and that is a problem because I wasn't able to find how to store, or maybe there is no way to store both the calls within that structure. So this solid structure is getting in the way of testing something that is really important. and that's a problem for me, for example. But in terms of outputs and reading the test and then understanding everything, I have a good experience with our unit tests and maintaining it. Yes, I mean, it's mostly intuitional to understand our unit tests, and the audience can see some of our unit tests in our public archives. Is it in archive, or I don't know? It's in repository.
They were like initially we had several. So when like several years ago we were using Travis CI instead of GitHub Actions, and we had multiple repositories in GitHub with public end-to-end tests. So that made real requests, and but first of all, like that's also one of the reasons why we have moved to HTML fixtures, because whenever when we started growing, like at the beginning there were like 6 different repositories or like 10, but when we started growing it would like grow to like tens or hundreds, like 10 for sure. It would be something about 100 repositories we had to update when we add new response fields and new target websites. I forgot your question, but yeah, understand. And then we added public test results, and then we removed them. So for now, there is no way to check how on publicly check our integration tests. So we present only badges. So we capture our spec output and we display our spec summary on each of documentation pages, and we display aggregated our spec summary on like groups of documentation pages. For example, Google Search APIs has other documentation pages. Documentation page there is a badge, and page there is a like aggregated badge.
I actually remember when I was running the company, I looked at them and then tried to come up with a different structure to test things. Yeah, even the outputs are actually really useful to have an idea about what kind of task should you have at the main level. I think it's really useful. Plus, let's say, so they serve the customer in some way because it's also showing the API's halt status. Like if there is some part of the button that is broken, it will show up there because of continuous testing. And let's see. Another thing that I would say that is good for continuously testing your suite or anything is that every time you have a pull request, you see a problem that it could create within another body. So that's actually a good way to check if you are doing a good job or if you are doing something too broad that is breaking the other parts. And I think that is subtle but really effective way of controlling the problems within a web scraping API.
Yeah, and we had another idea, like Julian had another idea that we started to implement in how our responses and about automatically updating our HTML fixture. So we have like AJ worked on that. So we added how it's said, like we have added mini playground on several documentation pages, and we had an idea like for Baidu, for
Yes.
images API,
Documentation
something
done.
like that. Yes, and HTML features on these documentation pages are like the idea was about continuously like have a cron job or something like that will regularly update save like HTML file in order to speed up load of the documentation page. And this HTML file can be like, since it will be updated daily, it can be used as a fixture to run a parser and run even run tests on it. And if anything is broken, then there is some parser bug or maybe something new on the search we have like tons of that use HTML fixtures. And another idea is to have a daily, like on daily schedule, execute all of these tests like for real, instead of using saved HTML file, make real requests and validate the response schema. That's two ideas working separately. Both of them are about like JSON schema, and like our tests basically testing schema, but we test them not using common tools, I would say. So we hard code different variances of JSON schema. So we have like different example groups in our spec files, and for each example group, we have several HTML fixtures with specific parameters, and we have a response schema that is written in a like nested example groups with different like hashes or field type. It's a schema. And we have like we may iterate like for example or two levels of nesting. So in organic results, there are expanded site links, and each expanded site link also have several fields. So there are like basically nested loops for each type of response field, for each type of HTML structure that's for each HTML fixture and parameters. And like also I'm thinking right now that like at the beginning of today's podcast, we have discussed it, or we briefly have discussed it, that we can use our real responses. We can use our real responses to store the variant, like to generate a more combined JSON schema of the variants, but we already have it, by the way, like in our unit, in our integration tests. But it's
spread out. That's the main problem.
it wouldn't help like it wouldn't help if like if we view like from like why customers would want schema. Can you hear me?
Yes, I can hear you. It's just cutting out because of my internet connection.
Yes, I guess it's my internet connection. Yep. What I wanted to say. I've asked like what was the initial like problem that why customer wanted to have a JSON schema. Like because
I have no
usually
idea. I have no idea about that. Why would anyone want that? I have
like
no idea. Because usually what you have, it's good to have, what you have in front of you, what
I
to expect.
know Yes, to what to expect in a programmatic way. So, like I initially wanted to have JSON schema to generate our SDK libraries like for Python, Node.js, and other languages because they are, yes, that's actually a valid problem. So our
I don't
to
know
be
though.
able
I mean, if
to
you're working on a project, I'm sorry to cut you out, but this is important because this, if you are working on a project and if you want this field, for example, and you want the order of organic results and the links within them, you don't need the complete
yes,
schema. You just
yeah,
need to know, oh, there are organic results and then there are links in it. So I just have to iterate through this array of organic results and then find that link or uh, whatever you want. So you don't actually need to learn the whole lot of it. And then from working on several projects using SerpApi, you can actually build up this information of coherence that you can use on other engines real quickly. You don't even need to work on any projects, like it's coherent already. Just go ahead. I'm sorry, I cut you out.
no. Thank you for adding your feedback. I thought like like the use case that I can think of for the JSON schema is to generate data models on the client side. By client side, I mean like someone who uses SERP API.
Introduction.
And exactly that's what about you are talking about. So organic result has label, and that's what like we care about, and we don't care about anything else. And if we mistype organic results or if we mistype label, then we will see that something is wrong during like before, like not in runtime, like before runtime, and that's what I would use JSON like response schema, uh, and that's the essence of like open API, I guess.
I don't know if that's the essence of OpenAPI. So it's OpenAPI. It's actually an automatic documentation system. That's you test endpoints, and it's not actually about giving response schema. Is just a byproduct of Open API. So it's also used for making a single type of API, so that if you switch between APIs, you don't have any problems as a customer. That's the aim of it. But I would say, like, for example, I use Fast API to create demo projects on several things, and I've used them in blog posts. And what I was seeing is that I never use JSON schema. I just use the automatic playground documentation thingy on Fast API, which is using Open API specification, and I just use it to test what I do or see the outcome. Like, that's no more than that. I don't use it to learn what I have written or see the overall picture or anything like that, because it also gives you like automatically created schemas for you to enter
Mm-hmm.
within the text fields. So it's also a plus. But
Mm-hmm.
that's also something we already do in our playground, for example. And it's actually better in the playground because you have like the options to click to. Everything is in front of you and it's in a nicely put way. I don't know
Mm-hmm.
if there is a better way, but it sure seems like a good way to me.
And by the way, we had another idea about this, like about the playground. So right now, when customers or users are evaluating Serp API, they are going to playground, going to documentation, making real requests, and so they consume real searches in order to build their code. And Julian had another idea previously to store sample responses to provide some sort of data for customers to write their client code without consuming like actual searches from like monthly subscription.
So you mean the cache search?
Maybe it's like so yes, maybe
Some
cache
kind
search.
of cache search that has all the keys, you mean?
Not all the keys, but so we already have several unmetered search queries that like the idea of unmetered search queries is to allow to build parser to build client code based on these queries. And yeah, I have to think more about it because I forgot about this idea. So we have talked about tests, we have talked about and you like about your experience. So you told about what you told about our spec is not about our spec, it's about how we structure our tests in order to test different response schemas in
Yes,
a
but there is also a problem with our spec about the scopes of the tests. Like there is when to use which how do you say, which block is important. Like you have to order them correctly, and sometimes it doesn't make any sense to a untrained eye or someone who just slept less, you know. It's not just about our structures. Our structures are actually good. If it's not forced on, it's good for all the situations.
And what is your experience of updating parsers or maintaining parsers or what else? Like basically, what's your experience working on parsers like here?
Well, working on parsers is enjoying. I'm enjoying it. Like it's joyful, I would say. Although it sounds a bit weird to enjoy updating and maintaining parsers, I enjoy them. But it is also a kind of stress runs through me if it is something that, like, on prioritizing what I should do first, I try to think about what is more important for the customer. And that part is more stressing than maintaining, because maintaining is fun. Like you're breaking things, you're bringing them together, and you're testing different things. And like I think everyone would agree with me who is on engineering in our team that updating passes is really fun stuff. It's the concerning part is satisfying the customer, and that is the concerning. Yeah, that is the concerning part.
What do you mean by
like if there is something broken on two places at the same time, which one to pick first? Because that's an important question.
prioritizing?
Mhm.
That's interesting question to discuss too. Usually, like I by myself, I check. I'm checking our internal dashboards, like proxy reports for each search engine, also error monitoring, also basically usage of multiple search engines. And
You are right, but even then you have a problem because most of our searches go through Google, for example. And we may have multiple breakings on Google. Which one to pick first? That's an interesting question. And then if you pick Google all the time, what happens to the other engines? Like there should be some giveaways that some of the engineers must make at some times. Like for example, if nobody's looking at Bing, then like that's actually a dynamic problem. How to prioritize fixes.
I mean, which fixes have the order priority between multiple. I come like prioritizing fixes because you have an idea, you have a good idea about what our customers are using, because you also check intercom and check GitHub issues, and you also interact with with users or potential users, Twitter and Reddit and Medium Reddit, but sometimes. And we know what people are talking about and what our customers are using, and also based on our previous experience of when something is broke Google, we know that we can guess the how much times per year it will be broken, like something like that. And also the importance, like if it's organic result title, is for sure, if it's not parsed, it's more important than like video results title or stuff like that. But we have like some customers who use intensively like YouTube API or Google API, so it's also an important thing. And
Yeah, I mean, while we're fixing Google, for example, something little in Google that no one cares about, maybe there is some customer that is mainly using YouTube API, and if that breaks, like it's doom level problem for them,
for
and
them, yes.
we might not get the idea of it. So that's another problem.
Yeah, but like Basecamp has I have an inspiration of this problem of prioritizing work from Basecamp. So they say, and that's a common sense, we can't help everyone. So what they say is they had several feature requests that were in the backlog like for years, and after several years, when for example, that's how we implemented Google Trends API. Someone wanted it, and then it became the most requested feature request. And the same is for Google Shopping right now, or Google Local Results. Like right now, we still can serve some Google Shopping results, but it's it's like a snowball. It's being broken step by step until it's completely broken. Right now, it works like okay. So regarding prioritization, yeah, I would say no, I would say nothing new to what you already know.
You actually remind me of something like, for example, in Google Shopping, we plan to separate Google Shopping, and there is a PR for that on the way, and it's actually being reviewed by Ilya. And so the reason to split Google Shopping into another engine than Google is actually good because we have enormous number of tests on Google. So
Mm-hmm.
if we can separate those
Mm-hmm.
tests and then look for the coherence within a specified section of the body that is still reusing some of the functions from Google, it's actually a good idea into maintaining it. Because if you have too many tests on something, you're not going to cache the details on each unit test. And I think a good way, I don't know if there is any byproducts of that event, but I think it's a good way to maintain a parser as well, like to specify what it's doing rather than adding any parameter to create a new function out of it, like what we do in Google, for example. And that's not intentionally done. Like it's how it's built at first. Like we have these TBM parameters that gets you through shopping results, news results, videos results, which all of these could be different engines. And it would be good to separate them into different engines. That is a good ground for unit testing as well.
And some like another idea has like also not mine, but I forgot about it, but right now I remember it. So right now, for all of our parsers, we have integration tests. So we don't test each specific method with specific, like for example, it's what Andy is doing. So in all of his, and Andy and Sebastian. So in all of their pull requests, they describe HTML structure for all of the variants, and so in the pull request, we'll already know the variants of the parser. And instead of having a complete HTML structure, it would be more useful to have like small HTML fixtures, specifically like for organic result, for single result, or for carousel, or for some part of knowledge graph, and or for like for whatever, except like for whatever that's already in HTML. It wouldn't work for like Google Trends, or it wouldn't work for Google Images because it's generated with JavaScript on the front end. But on for data that we extract from HTML, it would be interesting to have like small HTML fixtures with specific parts of response of HTML response, instead of having an entire HTML file for each. And like it would be good to have both. So right now we have parsers, like we have integration tests for parsers, but it would be also interesting to have unit tests for parsers. So instead of invoking like full search parsing stuff, we could invoke specific functions on our parsers, like provide, like pass some data to it, HTML data, and get the response, like response hash, only specific part. Interesting to see.
Yeah, that's an interesting idea. Yeah.
And we also had another idea. Right now, our parsers are not thread safe, but not thread safe, I mean, like, no, they are thread safe, but I mean, all of our parsing methods are mutating like a final hash or final response object. And instead of doing that, in order to speed up parser, I had another idea to return hash from each function, like get organic results, get knowledge graph, get Google Trends, get Twitter results, get videos, get people also ask, and stuff like that. And each of these functions could
Be running another thread.
Yes, to run it in multiple threads, each of these functions could return hash instead of mutating hash that's in instance object. And then after all of the threads are finished, we have hashes for each of specific parts of parser response. We merge it and return it. It would I like
The
because
problem I see with that is the exceptional case on some parsers. For example, on Google Organic Results, when we check for date, If we have a date, we don't give the rich snippet because this means that it should be served as a date and not as a rich snippet. And rich snippet, the parser for rich snippet is dependent on the parser for date. And this actually could be on another bodies. Like if something is in the ends, it shouldn't be on the organic results. I don't know if there is some part of it like that, but like dynamism could kill it. But overall, it's a good idea, I would say. Are you writing something about the subject again? Different HTML and single pass execution. I actually tried that with several projects when I was freelancing several years ago, and it's quite how do I say, like it's really hard to maintain because but I was using Selenium to extract these data, so there is that problem also. We are using a really lightweight method into parsing, so it would be possible for this framework. I don't know.
I wanted to say something else. You said Selenium, and before that, freelancing. I said multi-threaded.
Multi-threaded parsers, yeah.
Multi-threaded parsers. I wanted to say that our organic, so for now, Google organic results pages, like parsing, like data extraction from HTML right now takes 700 milliseconds. And it's a lot. And it's a subject to improvement. So because the target for us is to have it like ideally as fast as possible, like less than half a second, like ideally like 100 milliseconds. But we had like 2 years ago, we had a problem with Google Shopping API when on big HTML responses, our parsers, so execution of parser took 1 second, like from 1/2 second to sometimes like 9 seconds or something like that. We optimized it both on our side and on Nokogiri side and on libxml side. But right now, the problem with Google organic results is what Yicheng said. Like we have too many selectors, like so we try to support as much HTML versions as like HTML layouts as we could, and some of them are not
useful.
They are obsolete. There are much HTML layouts for now, but it still takes execution time on libxml sites that's used on Nokogiri. And we can improve it on our side by monitoring unused CSS selectors. And maybe we can start doing that based on our test suite. Or how else we can do that? I will think about it.
Place to start, yeah. Makes sense. Or a rake function, maybe. Or a combination of both. But here's the thing though. Google sometimes switches back to old streams. That's also another problem. So we need a way to store the CSS, but also at the same time use the current CSS.
And also another problem is for most of the proxies, Google don't return some of the responses that are present for real searches.
Yes. And I don't know. There is also this really interesting problem that we have is that, like, for example, I was working on Google Shopping API mobile and tablet versions, and we're going to open that soon. And the one problem that I realized is that its pagination is broken, and it's on Google side. So I have to apply that to the unit test. But if another engineer comes and sees that little part, I have to add some note into it that's saying, yes, we are taking it from Google, but it's broken. We also have a backup system somewhere else for another kinds of results without any pagination elements on the end. So it's like you have to, you shouldn't correct Google's mistakes, but it's also creating this unintuitional
Mhm.
unit testing structure
Mhm.
for the engineer that's going to work on it. And it's really interesting problem because the effects of it are rippling. It was just something that I wanted to say.
Yeah,
I'm sorry.
yes, and we can take advantage of some of these parts, and we can share it on Twitter or on other like social media platforms, because that's what at least SEO community like sometimes discussing some Google problems. And like an ideal solution for us with Google would be to somehow uh, be whitelisted for Google.
Be what? Come
Be
again?
whitelisted.
I like this.
Whitelisted. Yes, it's an ideal solution for scraping Google. I'm not sure if at some point we will be able to do that, but it would be, yeah, ideally,
I
like
don't
it
think
would
it
be.
it would matter much in terms of what we do. In terms of
I'm
proxy and proxy calling time and maintaining of proxies, it would make a huge impact. But in terms of unit testing and like Google is not going to serve, even if we're whitelisted, Google is not going to serve one kind of data. We still need to uh, find ways to organize a dynamic data. But yes, it would be an advantage.
like ideally it would be nice if search engines that we support would already provide an API. Yeah, that's like an original idea of why Serp API was created, but it's so weird because like they already present the data but in a different format, and it creates a business opportunity to provide like to restructure the format. But the problem itself, like with web scraping, creates like other industries like bot systems, anti-bot systems. But the actual problem under that is some of the websites don't provide a complete API when they could.
Yes, actually, yeah. I mean, any website out there, the best solution to prevent bots is to serve an API. That's actually good advice. Yeah, you're right. Um, but it's also, when I'm thinking about on that behalf, like it should be hard for them to serve an API because it's easier to serve an HTML structure because things could get like broken in it and then the user wouldn't even notice visually. But when it comes to JSON APIs, it's like you have to have near perfect structuring and serving and no errors as much as possible. So it's like a harder job to do.
I wouldn't agree because they have the same problem but internally. So they have their API and they have to structure it and make null free. I mean, to avoid uh, using, yeah, this part like
I
on
understand
their
which
on
I think it was Fire Query, something like that. Like they use this API in the background to serve the HTML. That's
I mean, even they have HTML templates or JavaScript that renders the data. They have data on their site, Google or other search engines, and they have some code that renders HTML from that. So it should be already synchronized with actual data. And if they would provide API instead of HTML, that wouldn't add, like that would create another product, but from what I from what I guess, it would be almost the same. So the only difference is number of users of their API. So right now it's internal for their templates. If they would open it, it would be like external, and they would have to serve it and maintain for tons of users. But
I think the main thing is that they cannot serve ads that easily on a JSON output. That's the exact reason. Like,
interesting.
but yes,
Interesting.
like Google actually has internal APIs, but for some reason they're not good. I have used a couple of them. Yeah, they're not that intuitional to implement.
I never thought about this, about web scraping from the perspective of not being able to serve ads. That's an interesting perspective.
You have missed a big point. It's all about ads. Internet is about ads.
Yeah.
Cool.
I guess we can
And
wrap
it's
up
actually
because
funny because like some of our customers, and like a good majority of them are on SEO, so they're also serving some websites to get themselves up on Google searches, and then these websites use ads, so it's like a cycle that is eating itself.
Mhm.
We are here because of ads. That's like it.
Cool. Interesting. I would suggest us to wrap up because I'm getting
Mhm.
tired, and we can have like second part of it in some future.
Yeah,
Be-
for sure.
so, do you want to add like any final notes before I wrap it up?
Not really. I mean, test everything and trust in ads.
Okay. Thank you for watching this podcast. We with Emirhan we're talking about how we continuously test and maintain a web data scraping API at SerpApi. We talked about HTML fixtures, about end-to-end tests, unit tests, integration tests, about our usage of them, about how we have used Travis CI to present our end-to-end tests to users who want it. And we also discussed several ideas about how to store and serve JSON schema for users and reasons to use JSON schema. We discussed our parsers, like Emirhan's experience about maintaining parsers, about writing tests and parsers at SerpApi. Then we discussed a bit the performance. We discussed a bit why web scraping even exists, and we also discussed machine learning for testing tests.
Testing tests, yeah, exactly.
Yes, and then we would need to have tests to test machine learning, and like
Well, that's called computer engineering, software engineering, metadata for metadata.
yeah, metaphysics. Okay, Thank you, Emirhan. It was fun to discuss it with you. Thank you for your help.
Yeah, thank you too for hosting this and giving us the pleasure to talk.
Okay. Thank you, all of our viewers. And by the way, we not only record this video but also stream it. So we record this video during a live stream. So please check out our Discord. I'm not Discord, our Twitch, and also our YouTube. So if you want to ask some questions, that would be, and you want to be some, if you want some questions to be discussed, please join live stream or comment, because the most fun for us, at least for me, is to answer some questions that are not mine but from actual people, so I am able to help someone. Cool. See you.
See you, everyone.